Welcome back, detectives. This is part 2, or Systems by Elimination Continued. It should be the back side of your page, or if you printed it off, then it would be 2 pages. This is just what do we do when variables are not so easy to eliminate in a system of equations. So it's still our same learning target, clue 2.5. I can solve a system of equations by elimination. But it's when things aren't quite as simple. So the first thing we need to figure out is what do we do when a variable doesn't have the same or opposite coefficient. So that's one of the first things that we do, right? When we're solving systems by elimination, we line up the two equations so that the variables and constants match up. And then we ask the question, do the variables have the same or opposite coefficients? And if they do, then we can immediately move on and add the two or subtract them, eliminate one of the variables, and move on and solve. But what do we do if the answer to that question is no? The variables don't have the same or opposite coefficients. And here's what we're going to do. We need to get them to be that way. So we're going to do a little we're going to multiply to get what we need. All right? So what we need is we need two variables, the same variable in each of the two equations to be opposites. That's what we need. So we're going to multiply to get what we need. So let's go ahead and do an example. Here we have 2x plus y equals 23. And then we have another equation, 3x plus 2y equals 37. Now, I'm looking and I don't see that I have two variables that have the same or opposite coefficients. The closest thing I see is I see that I have a y in the first one, y right here, and I have a 2y right there. So is there anything that I can do to make both of these be the same variable? Well, yes, there is. I could turn this y into a 2y, and really I want to turn it into a negative 2y because I want them to be opposite coefficients so that when I add them together, it'll just automatically eliminate or disappear. So I want to take my first equation and I want to turn that y into a negative 2y. So what do I have to multiply by that y to get a negative 2y? I have to multiply by negative 2. Now, here's the rule. I can't just change the y. If I'm going to multiply the y by negative 2, I have to multiply everything by negative 2. So that's what I'm going to do. I'm going to multiply negative 2 by everything in this equation. So negative 2 times 2x gives me negative 4x, and I'm just going to write it below like this. Negative, and remember it's kind of the distributive property here, negative 2 times y is negative 2y, and negative 2 times 23 is negative 46. Now that I've kind of changed my equation, the equation isn't any different. It's still the same equation. It's just been multiplied by 2. It's been doubled. And so that's a good thing about math, is you can do that. If you multiply everything in the equation by a number, it doesn't change the actual line. It's still the same line. So now I have negative 4x minus 2y equals negative 46. And I can now add that to my bottom equation, 3x plus 2y equals 37. And when I add them together, you'll see that I'm going to eliminate this 2y. So now I have negative 4x plus 3x gives me negative x. Negative 2y plus 2y gives me 0. And negative 47 plus a positive 37, well, let's see, that's going to be a negative. Looks like if I add 9 to that, 9 to the 37, it would give me 47, so a negative 9. So negative x equals negative 9. Not quite done yet, though. I still need to make sure that I have my x as an x and not as a negative. So when I multiply both sides by negative 1, I get x equals 9. Now that I know what x is, I can figure out what y is. So my x is 9. And let's figure out what my y is. So I'm going to take x for 9 and I'm going to plug it in to one of these equations. Doesn't really matter which one, but since that y is already by itself, that's going to make it pretty easy to solve. So I'm going to use the first one. Seems like I always use the first equation. So I'm going to say 2 times x, which I now know is 9, plus y equals 23. 2 times 9 is 18, plus y equals 23. Subtract 18 from both sides because I'm going to isolate my variable y, and I get y equals 23 minus 18 is 5, right? Y equals 5. So I'm going to go ahead and say that y is 5. Make this be a y there. Okay? So my point that would be a true statement for both of my equations is 9, 5. That means it's the place where the x and the y are the same in both of them. So 2 times 9 is 18, plus 5 makes 23. I just did a quick check of that one. 3 times 9 is 27. 27 plus 2 times 5 is 10, so 27 plus 10 is 37, so they both worked out. So I've just solved this system of equations using elimination, and I just had to do one little thing to make sure that I could actually eliminate a variable, and that was I multiplied the top equation by a negative 2. Sometimes we can do it that way. Other times we have to do a little bit more work. So let's look at this one down here. Here we have 4x plus 3y equals 8. Now, the second one says 3x minus 5y equals negative 23. So I'm looking at this and I'm saying, what can I multiply either my top equation by to get my x to be the same as this x, or my y to be the same as this y. So I'm looking and I don't see that I can easily multiply one equation or the other to get them to be one of my variables to be the same. So I'm going to have to do a little bit more work. So I'm going to pick a variable that I want to kind of make the same as the other. And I think the one that I'm going to pick is the x. And really I could pick the y too, but I'm going to go ahead and pick the x. And I'm going to look at 4x and I'm going to say, what do I need to multiply 4x by? And what am I going to need to multiply 3x by so that I could get them both to be the same value, actually one being a negative and the other one be a positive. And really, probably the only thing that I can multiply them both by, or the number that they're going to have in common, that least common multiple is going to be 12. I could make this one be 12x and this one down here be negative 12x. So I think that's what I'm going to do, is I'm going to work towards making the 4x plus 3y equals 8 be a 12x, and the 3x minus 5y equals negative 23, have the x be a negative 12x. So what do I have to do to get 4x to be in 12x? Well, I have to multiply it by negative 3. or no, I'll just multiply it by 3 to get a 12x. So 3x times 4x, 3 times 4x, 3 times 3y, and 3 times 8 gives me 3 times 4x is 12x, 3 times 3y is positive 9y, and 3 times 8 gives me 24. Now that I have that as an x, a positive x, I'm going to turn my other one into a negative 12x. So what do I have to multiply 3x by to get a negative 12x? Well, I have to multiply it by negative 4. So I'm going to multiply the 3x by negative 4. I'm going to multiply the negative 5y by negative 4. And I'm going to multiply the negative 23 by negative 4. So negative 4 times 3x is a negative 12x. Negative 4 times negative 5 is a positive 20y. And negative 4 times negative 23, 24 times would be 80. 4 times would be 12. 80 and 12 makes 92. And I have two negatives, so it's going to be a positive 92. Now that I have a 12x on the top and a negative 12x on the bottom, I can add these two together. And I come up with 0 plus 29y equals, let's see, that's a 6, 116. 116. This is interesting. So now I have 29y equals 116. And I am going to divide both sides by 29. And I have y equals 116 divided by 29. Well, I'm going to see what that is. I'm going to do that over here. 116 divided by 29. What if I try 4? And I'm picking 4 because 4 times 9 is 36, and I'm hoping that it's going to be an even number. So 4 times 9 is 36. Carry the 3. 4 times 2 is 8, plus 3 more is 11. Ah, hooray, 116 with 0. So 29 goes into 116 4 times. So that means y equals 4. All right, let me go over here. Remember what I'm working towards. Figuring out my x and my y. So here's y, here's x, and my y is 4. Not done yet. Why don't you see if you can figure out what the x is? See if you can figure out what the x is. All right, so what did you do? How did you figure out what x was? Hopefully this is what you did. You picked one of these equations. Doesn't really matter which one. I'm just going to, again, like always, pick the top one just because the smaller the numbers, the happier I am. And I'm going to say 4x plus 3y, but instead of writing y, I'm going to replace y with 4 because I now know that y equals 4 equals 8. That means 4x plus 12 equals 8 minus 12. From both sides, I get 4x equals negative 4. Divide by 4, divide by 4, I get x equals negative 1. So x equals negative 1. I'm going to double check myself by putting negative 1 in for x and 4 in for y on both of these to just make sure that it works in both of them, because that's the only way I know for sure that it is a common point, is if it is a true statement in both of them. 4 times negative 1 is negative 4. Negative 4 plus 3 times 4 is 12, so negative 4 plus 12 is a positive 8. Works on that one. 3 times negative 1 is negative 3 minus 5 times 4 is 20. So negative 3 minus 20 is a negative 23, and that's what I have there. So again, it worked on both of them. So negative 1, 4 is the place where the two lines intersect, the one point that is common between the two equations. All right? Now, this is really, I just wanted to show you how to do this because you are going to have to do this. Sometimes you're going to have to move things around, just really kind of manipulate your equations a little bit so that you can get either your x's the same or your y's the same. So, your x's opposites or your y's opposites, so that you can eliminate one variable or the other. Sometimes all you have to do is multiply one of the equations by something and you'll be able to get that variable, the coefficient, the opposite of the other one. And then that's pretty quick and easy. Sometimes you have to multiply both of the equations by something to be able to come up with something common. So this is where you get to be a little creative. You could have chosen to multiply, you could have chosen to eliminate your y's, and then you would have had to multiply your top equation by 5 and your bottom equation by 3, and then you wouldn't have had to make it be a negative 3 because this would have ended up being a negative 15. This one would have been a positive 15. You would have eliminated them. It still would have come out. You still would have come up with negative 1, 4. If you don't believe me, try it and see. As long as you're doing your math correctly, you're going to end up with the same answer. So that's what's cool about elimination and having all of these different options. You can pick and choose how you want to do it. So the important thing to remember is that whatever you do to one part of the equation, you must do to the entire equation. So when I'm trying to turn my x or my y into something specific and I'm multiplying it by another number, I have to remember that I multiply everything in that equation by that number to keep it all balanced and equal. So that's an important thing. Now's the time for you to write down a key idea, something that is important for you to remember, something that if you write it down and you read it, you would be, oh yeah, I know how to do this. So think about the key idea or key ideas and write them down in this bottom section. And that's all I have on this. I hope that you understand how to solve systems by elimination, and you can do it the easy way, but sometimes it's not so simple and you have to do a little bit of changing up and working with your equation, and now you know you can just multiply things and get the numbers that you need so that you can eliminate. I'll see you in class.